Thank you, Bastian, and very much appreciate the opportunity to talk to the wider European community and Euro-friend community about work that we've been doing around historical drought, how important it is in terms of managing climate variability and change in the water sector, but also understanding how change has been happening historically and informing us of how best to adapt into the future. So before I start, I just want to recognize the different funding agencies involved and indeed a lot of different collaborators, both from Ireland and further afield over the years in the work that I want to present today. So I guess each of us have a favorite paper or a short number of favorite papers that we've read. And one of mine has to be the paper on the top right there by Glenn McGregor, talking about climatology in support of climate risk management, offering a progress report. And what was inspiring to me about this paper is that it looks across the range of different data sets, tools available to us in order to build resilience in terms of responding to climate risks. And I often ask the question of myself, what would this look like if we wrote that paper in terms of a hydrology focus rather than just a climate focus? And particularly looking at the role of historical hydroclimatology and how it can be used for better informing decision-making both now and in the future. So following on from that paper, work that I've been doing over the last number of years has really been trying to gather information, extend records back in time in order to look at past extreme events, particularly looking at historical droughts, but also using different approaches in order to not just understand historical droughts, but to quality assure historical records. Because without quality assurance, making interpretations from long-term records can be fraught with difficulties. So I guess if we were to look at the literature, approaches to understanding historical drought, we might characterize them into different typologies or approaches, from using historical data rescue, lots of work done in climatology in terms of rescuing temperature data sets, precipitation data sets. But of particular value for understanding historical droughts are historical data around sea level pressure, and also extending data rescue activities into hydrology, such as for rescuing river flow records. We have documentary records and proxy data, for example, tree rings, lots of important work being done on the use of oxygen isotopes, particularly for summer precipitation. And we have really nice data sets now, like the Old World Drought Atlas, that give us insight into proxy representations of historical droughts. We also have statistical methods and modeling that can help us to reconstruct long-term data sets. When it comes to thinking about things like quality assurance and homogenization methods, relative methods and algorithms like Homer, for example, that are widely used for homogenizing precipitation data sets are not really applicable for long-term records because the density of networks can be quite minimal and we're forced to use alternative methods. One of the things I want to focus on in the talk is about how we're using statistical methods, particularly regression-based techniques, simple approaches, in order to reconstruct and evaluate historical droughts and the quality of historical precipitation records. And then more recently, we have things like reforecast, reanalysis, people like Wilson Chan and others really leading the field in terms of use of such toolkits for developing drought storylines. And of course, hybrid approaches that draw across each of the different areas. So in my talk, I wanted to delve into briefly, there are 6 parts to it, that's a lot I know, but it's really a storytelling exercise in terms of some of the things we've been doing and some of the insights gained in terms of leveraging more value from historical records for understanding past droughts and how reconstructions can inform or improve our understanding of past records. And to really think then about how the work that we're doing here is feeding into policy in terms of planning for water infrastructure, operational issues around meeting water demands and water supplies for a major European city in Dublin, which, believe it or not, coming from Ireland, talking about drought, is a city on the edge when it comes to water resource availability and vulnerability to droughts. In preparation, I was looking at the last presentations and Bastian highlighting the different working groups of Eurofriend. And I think that across each of the working groups, there will be something of interest for those in the audience involved in the different working groups. So I'm going to start with a very brief overview of historical data rescue work. Of course, basic variables such as precipitation, having long records is crucially important to understanding historical extreme events and historical droughts. In Ireland, we are lucky to have very long records, but not all of them are available in digital form, are available to scrutiny by scientists. So therefore, we've spent a lot of work in the last number of years in both digitizing and transcribing and quality assuring the available precipitation records. These images are from the library in Met Éireann, which is our Met service in the Republic of Ireland. And we've been investing in terms of equipment, scanners, in order to improve the efficiency of data rescue and making that data available to science. And across both the British and Irish Isles, this investment in rescuing historical precipitation records is really opening new opportunities for understanding historical droughts. We've been working in Maynooth at integrating data rescue into the classroom. In my third year class, we typically have 200 students, and getting them to help out and contribute to the scientific endeavor through doing some data rescue and analysis has been hugely successful. And working with colleagues in the UK, particularly Professor Ed Hawkins at the University of Reading, where during COVID lockdown was successful in rescuing millions of historical monthly rainfall observations from across the British and Irish Islands. But more recently, we've also been extending our work to hydrometric data rescue. There are, again, records available in paper form for many river catchments across Ireland, and the same in the UK and elsewhere, that are on paper, and developing approaches and methods for rescuing and quality assuring that data is of fundamental importance to understanding past data. One of the key data sets to have come out of our data rescue efforts is the Island of Ireland Precipitation Network. This is a long-term monthly rainfall network, 25 stations or so distributed across the island of Ireland, that we're using for understanding past climate variability and change in historical drought. These data sets are all homogenized using the previously mentioned Homer algorithms available in R, and therefore are good for use in understanding historical droughts. And one of the key applications so far of that data set, now due for update, I would note, is that we did an analysis of historical droughts from Irish Precipitation Network, historical droughts from across that network for Ireland. And this is what we call the DNA of Irish droughts, showing the occurrence for SPI 12, the occurrence of extreme and severe droughts, in particular in the historical record for each of the individual stations in the Island of Ireland precipitation series. And what becomes immediately apparent from this, it ends in 2016, but what is still apparent from it is the paucity or lack of droughts since the mid-1970s on the island of Ireland. There have been a few drought events at individual stations, but the lack of an island-wide extreme drought by the SPI metric has really been lacking. And that has brought us to realize that drought is perhaps what we might call a forgotten hazard in Ireland. A lot of the development in terms of housing, water demand, water infrastructure has happened since the 1970s, but yet we haven't had a major event to really stress test those investments. So given the typically short record lengths for river flows, for example, start in the 1970s when water managers realized actually we need to monitor this. We don't have long records across much of the country. So a lot of work we've been doing has been on understanding these historical drought events in more detail. When we zoom in on some of the drought-rich periods from that DNA of Irish drought, you can see very clearly the diversity and complexity of different drought signatures. So these are different drought-rich periods in the historical record, the most recently being in the 1970s, and how the propagation of drought through time here and across the island of Ireland is very different in each circumstance, and each one of those individual drought-rich periods offering a different challenge to water resource management. So we've been working with our water management agencies and trying to integrate these different drought signatures into planning for stress testing infrastructure and for beginning to think about climate change adaptation in particular. To supplement work with historical records, we've also been delving into drought impacts, particularly through the soon to be published Irish Drought Impacts database. The database is out there on Pangea, papers soon to appear in Geosciences Data Journal. And it's a deep delve into newspaper records in Ireland, getting back to 1733, over 6,000 individual impact reports across different sectors, which we were inspired by the European Drought Impact Database, that allows us insight into understanding not just variability and change in droughts from a meteorological perspective, but also from an economic, social, and societal perspective from looking at these drought events. Particularly noteworthy, if we just look at agriculture and public water supply, is, I guess, the decreasing trend in reported impacts for agriculture and livestock over time, and the increasing trend in reported impacts in newspapers from a water resource and water supply perspective, indicating an increased vulnerability to droughts from in the water sector in Ireland. In terms of engagement and understanding the cultural importance of historical droughts, the newspaper records really open up insight into how droughts have affected society in different ways and provide unique insights into the responses of different people to drought events in the past. And this has been wonderful in terms of engagement, in terms of getting media traction and being able to engage members of the public about the importance of historical drought and re-remembering, if you like, the importance of droughts in the national context. The one in the middle here is a drought event in 1806. It's a beautiful poem that appeared in the Belfast newsletter talking about the different impacts of drought across Northern Ireland in particular, from on the rivers of the region, on the Bann and the Lagan, in terms of impacts on agriculture, but critically on the linen industry in Northern Ireland, and how it was dramatically impacted by a lack of energy, I guess, from hydropower at the time. And on the right-hand side is a really novel, I guess, weather engineering intervention or suggestion in the Irish Times from 1893, with a suggestion to explode dynamite to try and bring on the rain over Dublin due to a failure of water supply in the city in 1893. I'll come back to those documentary sources and impacts later on in the presentation. But it's fair to say over the British and Irish Isles, we have some of the longest running continuous records of anywhere in the world. And as I mentioned, being able to quality assure some of the early records is sometimes challenging because of the paucity of a large density of stations to evaluate homogeneity. So many of these long-term records have not been subject to much quality assurance. And one of the key records in this region is the England and Wales Precipitation Series. It starts in 1766 as a monthly series, continuing up to present, and is widely used in understanding historical drought, but also for understanding variability and change, for things like verifying climate projections, etc. Wide use are for verifying proxy reconstructions. One of the things that became apparent in looking at the England and Wales Precipitation Series is the presence in the winter series in particular of this increase, or at least the appearance of significant trends in the time series for records that commenced before 1850. If we start an analysis of winter trends after 1850, there's a lack of significant increasing trends in here. This is ending in 2000, by the way. But when we start our trend analysis before 1850, we have this period or this area of significant increasing trends after this period. And that raised some interest to ask the question, well, can we use approaches to reconstructing precipitation records to inform what might be going on in the England and Wales Precipitation Series? And there are lots of avenues for doing so because of data rescue efforts, things like newly available sea level pressure series from projects over the years, work that people in historical climatology have been doing to develop things like the Westerly Index as a surrogate for the NAO. We were interested to ask, can we reconstruct this to see what might be going on here in the long-term winter series in EWP? What can it tell us about the quality of early precipitation records? For context, the England and Wales Precipitation Series represents rainfall over England and Wales, and it's made up of a composite of stations from 5 different regions. Each of these different regions has a number of contributing rainfall stations, but as we go back in time, in the middle here, you can see the number of stations contributing from each region decreases substantially. So that as we get past or back before 1850, for example, we're down to 3 stations, 2 in some stations, then down to 2, and then down to a single station for the earliest part of the record. And this is particularly of relevance for the pre-1850 data. So the question we were asking is, can we use statistical techniques to reconstruct the early EWP series? And we did so using predictors, using simple regression, such as the Central England temperature series, which we know warm winters tend to be wetter. The Westerly Index, developed by Pario Pedro and Wheeler et al., is a measure of persistence of westerly winds taken from ship logbooks that has been well established as a surrogate for westerly airflow and a surrogate for the North Atlantic Oscillation. People like Richard Corns have developed long-term sea level pressure observations in London and other work in Paris, for example, and they've been able to develop not just the sea level pressure series for London, but also what we call the Paris-London Index, which again is another measure of westerly airflow and a surrogate for the North Atlantic Oscillation. Others have gridded reconstructions of sea level pressure based on data rescue, such as the work by Cuttle et al. And others have developed long-term measures of other key modes of climate variability in the region, like the EU2 index, which is often associated with Rossby wave propagation, looking at zonal pressure differences across Central Europe. So taking these different predictors, we developed different models of the England and Wales precipitation series. And this is the winter series for EWP on a decadal basis. The red line is the observations, and the rest of the lines are our model reconstructions, 36 in total. Calibrating our models on a contemporary period, evaluating them in the central part of the chart here, and then using them to reconstruct the historical record. And you can see quite clearly that there is a large deviation occurs in the pre-1850 period. This is 1850, so just after 1850, 1860, thereabouts, we can see this large-scale deviation where our model reconstructions are lying considerably above the decadal totals for the observed winter precipitation. And indeed, when we look at the trend analysis from the observed, which you've just seen, where we see this significant trend from 1850 onwards, it disappears in our reconstructions. That significant increasing trend in winter precipitation totals in the EWP series is not in our reconstructions. So that raises some suspicions that we developed or delved into in order to understand better what might be going on. A couple of things we looked at, of course, to check this, given that this is such an iconic series, is looking to see if there were cold biases, looking at colder than average years in the England and Wales precipitation series, both pre-1870 and post-1870. The red here is the post-1870 record, and the blue is the pre-1870 record. And you can see that there is a slight dry bias in the pre-1870 record for colder winter conditions. We'll come back to that in a moment. In terms of our model, works very well for other seasons, just an example of for spring and for autumn on the right-hand side. And we also looked into what was happening in terms of gauge development and gauge exposure at this time. The person in the photograph here is George Simmons. He was ultimately responsible for developing British rainfall, of establishing standards for measuring precipitation, gauge design, gauge exposure, and played a crucial part as, I guess, the father of the observational network that we have now. And around the 1860s, 1870s, reported in British rainfall at the time are field experiments at looking at the influence of different gauge designs and indeed the elevation of gauges above ground surface in terms of their influence on rain catch. There's a beautiful graph on the right-hand side that shows how the elevation of the gauge above ground surfaces reduces the amount of rainfall caught because of wind-driven losses. So around 1865, these things were starting to be considered. But it's not just the positioning of gauges that was changing. This is a paper from 1891 from George Simmons himself, who talks about how the change in gauge design around the period of the 1860s as well was crucially important, particularly around the measurement of snowfall. From his paper to the Royal Meteorological Society, he highlights that in England, until the introduction of the Snowdon pattern rain gauge in 1864, the funnel of the gauge always reached almost to the top. And that was a pity because if not surrounded by a rim, if a fall of snow was accompanied by wind, hardly any of the snow would be left in the funnel. And he raised a concern in this paper that he was afraid that most of the early English records for winter were likely too small or too low, owing to insufficient attention to the measurement of snowfall. And indeed, when we go to some of the well-documented long-term stations that contribute to the England and Wales precipitation series, such as the series at Oxford, Hurt and Hoden highlight the fact that they are unsure whether snowfall was included in early measurements or when snowfall was included as precipitation in the annual totals. Looking back at the ledgers, there's clearly reference to snowfall events for which there's no equivalent total given in the records. And indeed, since then, work that's happened since publication of the paper, we can see again from the annual rainfall sheets for the UK that are available, some stations here showing the occurrence of rain, or sorry, the occurrence of snow, but the lack of a total included in the observations. And this is included for different stations within the observational network. So as a result, we further investigated what might be happening in these early records by looking for some data sets on snowfall in historical context. Very little available, but did come across work by Gordon Manley published in 1969 in the journal Weather. And Gordon Manley, who's famous for the Central England temperature record, actually produced a sleet and snow series for southern England, looking at the occurrence of sleet and snow days across the Greater London area, getting back to 1668. For the hydrologists among us, interesting to note that his research assistant at the time went on to be a very famous hydrologist. That's Professor Elizabeth Shaw. So the data set was included in the journal paper, but no data was available. So one of the highlights of my career to date has been traveling to Cambridge to Manley's original written notes and transcribing this data to produce or to reproduce the series that he published in 1969. And this is the London Sleet and Snow series here. And you can see very clearly that in the early record, there are periods of time when there is enhanced occurrence of sleet and snow, particularly in the pre-1850 period. And when we look at the residuals in our model reconstructions, so the difference between the observations and each of our 36 different models, when we look at the inverse for presentation, we can see very clearly that the residuals show a strong coherence or covariation with the occurrence of sleet and snow in the early record. So ultimately, it's telling us that the early winter series in England and Wales precipitation may be too low, and that has implications for our understanding of historical droughts, particularly multi-seasonal droughts and multi-annual droughts across the region. But it's important to note that it's unlikely to be an EWP issue only. This is a record from Ireland, and you can see for the month of February, it's just written in here on the sheet, snow this month and no total recorded. So what does this work on reconstructing precipitation tell us? There's significant divergence between observed and reconstructed precipitation in the England and Wales winter series pre-1870. That divergence aligns with the introduction of new gauge design and changes in measurement practice. And ultimately, even the trend to wetter winters, and again, I'll emphasize the series I was showing and working with ended in 2000, but that increasing trend from 1850 for records tests beginning before 1850 is likely in substantial part an artifact of measurement practice and the higher occurrence of snowfall in early winters. And it's probably the case that this has distorted many other long-term European precipitation series, particularly in Britain and Ireland, but also further afield. And that biases our understanding of early drought conditions in these long-term records, particularly of long drought events, multi-seasonal, multi-annual, of relevance for water management today. So following on from these insights, we continued working with long-term regional series. There are others to see if this was an issue in those records and what reconstruction could tell us about drought events that might be of note in the reconstructed series. In Ireland, we have this long-term 305-year precipitation record that takes advantage of the island of Ireland precipitation record to 1850 and uses other sources, including documentary sources and early precipitation observations prior to that to extend back to 1711. This is an indication of the annual and seasonal totals in this record. We have some suspicions in the paper published about the early winter series in particular being too dry. and part of the early summer series perhaps being too high or too wet. But it gives us a really long-term span of what might be happening in terms of precipitation records in Ireland, and gives us insight into major events in the past, like 1740, which is known as Blian on Air, or Year of the Slaughter, and Forgotten Famine in Ireland. And this period of the 1740s is also well recognized as being a highly unusual time for climate in northwestern Europe. In Scotland, we have a Scottish precipitation series published by Keith Smith in 1995, and it dates back from 1752 onwards. So taken together for England and Wales, for Ireland and for Scotland, there are some really valuable long-term records that we need to investigate. So using the same approaches for England and Wales precipitation, we reconstructed precipitation in these records. We did so monthly rather than just seasonally in previous work, just to check consistency, but also so that we could develop or reevaluate droughts by applying standardized precipitation index in this case. So similar predictors, I won't go into those details. Again, just to show that in training our models for EWP on the left, Ireland, or IOI for Island of Ireland in the middle, and Scotland on the right, models perform really well in calibration and indeed in evaluation. So what do the reconstructions tell us? Just to note, for England and Wales precipitation, these are the monthly reconstructions. The red is the observations and the black are the reconstructions. Again, shows similar signals for winter, but also show up perhaps that some of the early summer precipitation records in EWP might be a little too high. This is a comparison, for example, between some long-term well understood stations from Carlisle, Manchester, Kew, Oxford, Spalding, and Edinburgh, in comparison to reconstructions in red. And you can see here the early EWP record for May, June, July, and August is peaking its head up above the other two series, the mean of the observed series and the reconstructions. There are similar biases, particularly in winter, in the Irish record. Again, the early record for the observations being too low in winter seasons are also evident in the Scottish series, which again emphasizes the importance of thinking about what was measured, is it necessarily precipitation in the early records. So with these reconstructions, we were able to apply the standardized precipitation index. Again, many of you will be familiar with this in terms of determining when a drought commences to when it ends, and looking at drought severity or accumulated deficits over time. Again, these are just the next three slides are just comparing the observed and the simulated standardized precipitation index, SPI 12 in this case, for the observed and the reconstructed. The red is the observed, the black is the reconstructed. And where we have these blue columns, they're extreme droughts, and the orange are severe drought events. And what we can see, particularly for EWP, is that there's strong agreement after 1870, quite remarkable agreement, if you ask me, in terms of the ability to reconstruct these events, and strong coherence in terms of not just the occurrence, but also the categorization of an event as being moderate, severe, or extreme. But prior to 1870, there is some deviation that has potential impacts on our understanding of historical drought in the region. The table on the bottom here is from Terry Marsh et al. In weather, looking at historical droughts in England and Wales. And you can see, for example, just to point on one for the moment, 1798 to 1808 as a long drought. They highlight perhaps a separate drought, non-overlapping periods, but that there's limited hydrological evidence and further investigation is required. So if we look at 1798 here, we can see, 1798 to 1808, we can see this, I guess, deviation between the model reconstructions and the observations here. That may be a reason as to why there is limited hydrological evidence for that being an extreme drought event. What is of note, however, I want to draw attention to is this drought event that commences around 1765 and runs to 1768 as being the biggest drought event, the most extreme drought event in our reconstructions. And in the very early EWP series, there is evidence of, I guess, a downturn or dry conditions at that period. But we'll come back to that in the other reconstructed series as well. For the island of Ireland, again, very good agreement for the island of Ireland in the period after 1870. Again, recognizing the lack of extreme drought conditions in the last 30, 40, almost 50 years in Ireland, 2018 being the exception. But again, when we look back at the early record, there's some deviation here between the observed and the reconstructed, where some extreme drought events in the observations just don't appear in the reconstructions. And again, I'll bring attention to this drought in 1765. It is in the observations, but it's also well captured in the reconstructions. And again, is the most extreme standout event in terms of duration, accumulated deficit and severity in the entire reconstructed series. And similarly for Scotland, good representation in the period after 1870s, some deviations in the period pre to 1870, but again, this drought event in 1765 standing out as remarkable in the long-term context. And again, looking at documentary evidence, there is lots of evidence for this drought event in 1765, but there's a lack of discussion about it in the academic literature. John Rutty, a physician in Dublin at the time, noted an extreme drought, trees dropping their leaves for want of moisture, a lack of grass for cattle, and issues around milk and butter supply for the poor. Oscar Wilde's father, William Wilde, who was very much into historical extreme events, notes a very dry summer and parching northeast winds, extreme drought in Ireland in summer. In Scotland, Sinclair, 1794, notes the issues for livestock around sheep and cattle in terms of access to grassland and disease. And in an Irish newspaper called the Freeman's Journal in August, it talks of the long drought conditions in the UK, in England and Wales at the time, and that prayers are being issued for the arrival of rain, and that such responses have been ongoing across Ireland up to that time. Historians recognize 1765 drought event. In particular, the White Boy movement in Ireland were agrarian agitators who suddenly went quiet in 1766. And historians note that this was due to hardship in the country. And they recognize a major river like the Shannon was dry, crossable by foot in 1765. And again, newly available observations show us that 1765 was indeed particularly dry, driven by a dry summer and subsequent extremely dry winters. So again, we need to be careful in reconstructions. Some winters were dry. It's not that snowfall wasn't being recorded. And that's why these reconstructions are so important. So each of these stations show the evidence. For example, here in Linden in the UK for 1765, really dry summer, and then a succession of dry winters in the following years. And again, the evidence is there from multiple stations. This was indeed a widespread drought event. So the insights gained, just conscious of time, shows that historical records offer deep insights into the nature of extremes of past, well beyond the experience of observations. And that with these kind of reconstructions that leverage other data rescue activities for meteorological variables, particularly sea level pressure, we now have new methods to examine the quality of early records. And beyond the historical and cultural interest, the historical droughts that we're able to develop because of that offers us a library of extreme events to stress test existing water supplies. There's a diversity of information, therefore, for investment decisions, for future planning. And from the context of the UK and Ireland, 1765 from the reconstructions would suggest that 1765 is the drought that perhaps offers the most extreme benchmark drought event in more than 250 years. We've been extending our work on reconstructing and reevaluating drought to river flow records in Ireland in terms of using hydrological models and artificial neural networks together with rainfall reconstructions in order to develop river flow reconstructions for catchments, 51 catchments across the island of Ireland. Again, these are building off the Irish reference network and in order to extend the records for these good quality stations. And we've been able to, again, look back and for each of these different catchment types, begin to cluster them in terms of different types of catchment responses and how droughts are propagated from meteorological events through to hydrological events. and use these long-term reconstructions to get a better handle on trends in drought characteristics, such as in duration or in severity or accumulated deficits. We're seeing ultimately in the long-term records in Ireland a decreasing trend in the duration of droughts, but an increase in the severity and intensity of droughts. And again, we have a catalogue based on each of the different catchment types of different extreme events that are of most relevance based on local hydrology. Coming back to the newspaper impacts, again, we've been able to use the hybrid approach, I guess, to thinking about how we can use these river flow reconstructions, linking them with the availability of impact records from data sets from newspapers in order to identify thresholds for drought monitoring and drought warning, where, for example, we begin to see the emergence or a high probability of the emergence of newspaper reports of drought impacts throughout different months of the year. You can notice, for example, in the summer months here for SPI3, well, at the catchment scale, each one of these are different clusters of catchments that even at very moderate deficits for SPI3, we have a high probability of impacts appearing in newspaper records, particularly in the east of the country. So Ireland is not immune to droughts and is actually very susceptible, particularly in the areas of public water supply. Which brings me to my final point and ongoing work. So this work is great in terms of academic interest, but it's important to be able to integrate it into decision making, and particularly in stress testing investments. So Dublin, Greater Dublin region is a population of about 1.7 million people. Its water supply system is very much on the edge. There's a very small headroom, 2%, something like that, to deal with extreme events. We've had a nationwide hosepipe ban in 2018, and even that statement is taken from Irish Water's, our national water utilities website. Demand for treated drinking water in Dublin reaches critical levels. That's from January of this year, a very wet winter, and even during those conditions, struggling to meet demand for water resources. There's a lot of investment at the moment about to take place in terms of water resources in Dublin, and even talk of a new supply and an interbasin transfer from the west of Ireland, from the Shannon, to provide water to Dublin. In drought planning work, for example, 2018 is used as the drought event for planning. But we know from these historical records, being able to contextualize that while 2018 might have been a short, sharp event, it pales in comparison with historical records. So we've been working to move away from the large-scale regional series to developing a more bespoke regional series a bespoke series for the Greater Dublin region to inform water management in this location. So using similar approaches, the data rescue work undertaken at Maynooth, but also through Ed Hawkins and his data rescue with citizen scientists, have meant we've been able to extend rainfall records for the Greater Dublin area back to 1860s for that area in red, and the upland area as far back as the 1910s. And again, using available sea level pressure series for Dublin and things like the Paris-London Index and London sea level pressure, being able to extend these series back in time. And a PhD student at the moment is working on these. And what we're finding is quite exciting in terms of our ability to be able to extend these observations back in time. So these are May, June, July, and August reconstructions for the Greater Dublin area. Again, a comparison of different approaches relative to the observations. But what's even more exciting is that we're able to use available tree-ring oxygen isotope information in order to extend that series all the way back to 1200. Not the done deal as yet, but there's strong possibilities there in order to extend those records even further back in time. So final reflections for me. Better understanding historical drought is crucial for better water management. I think being able to reconstruct, reevaluate, and even develop long-term records in the first place and understanding historical drought is a key starting point for climate change adaptation and increasing the resilience of existing systems, especially given the limitations of climate model projections for drought and issues around blocking persistence and those kinds of issues. Opportunities exist to extend our understanding and more rigorous quality assurance through reconstruction and deployment of hybrid methods that leverage data rescue and available proxy data. And that these opportunities extend not just to meteorological drought, but to all drought types, and are crucially important where record length is limited. So thank you, Basti. Back to you.